Hey there, this is Tony Dubiel, Cloud Architect from Cisco. Today I'm going to provide you with a very brief demonstration of using your laptop and specifically following this link from GitHub, Docker Labs, to pull down some information and some files to create an application, some code and a web server. It's a web server that shows updated images of cats. We're going to take that, containerize it, build an image, and we're going to deploy it using Cisco's curated container orchestration solution that is called Mantl. Mantl is built using a full container stack that you can see here. Each one of these layers and services will be represented as part of this demonstration. The full stack is actually a collection of open source tool sets, which again is curated and stitched together with some unique glue code developed by Cisco, which is also open source and available free on GitHub. Now, these are the files based from the GitHub link that I provided earlier as part of the lab from Docker. Essentially what we're going to do here is use a Docker file. We're going to create a Docker file that will compile together a Python script where we have updated code, requirements text that will point to the requirements, as well as a web page that we will use to point to a viz feed and collection of images of various cats. We'll just walk through this briefly. These are the sections that I needed to complete in order to compile together, again, these templates and code. Upon completion of the Docker lab, I have a collection of files that I can list out here in my Python script and code. The Docker file itself, requirements.txt, and inside of the within templates directory there is a HTML index file for the web server. From the contents of the Docker file, we observe that we can actually pull down the Alpine web server, update Python pip, as well as copy the app.py code and the web page, the index HTML, and expose port 5000 for the container, and then ultimately run the code within the container. As we build the Docker file, this is the output that we see. To avoid overlapping ports, we can build the container with whatever port we decide to configure. Now with our newly created Docker container, we can log into the Docker Hub using our account and create an image that we can make publicly available. Now notice the My First App at the top here, that container. We can go ahead and we'll push that as an image into the Docker Hub. It'll just take a few minutes. Let's go ahead and search for /myfirstapp in my Docker Hub. Now let's use this public image to launch the My First App into the Cisco Mantl using Postman in the API. At this point, I'm setting the global parameter My First App as the app name to launch in Postman script. In the API, we have quite a bit going on. We're going to post to Mantl, and we're going to set quite a few parameters here for the Docker container. We're going to use that image, that public image that we pushed into Docker Hub. We're going to use JSON as the syntax that we'll use to communicate to Marathon, which is a component of our Mantl orchestration solution. We're going to consume some resources here, a fraction of a virtual CPU, as we just saw, and some memory. And if everything succeeds, then we would see results such as what you're seeing on the screen. So we'll go ahead and now validate that within Marathon to make sure that My First App is running, which we see. We actually have a single container based off of the Docker configuration that we configured from the API call. Also adding ports, a service port, a unique port that we can identify in traffic, which is a load balancer and a reverse proxy. As we scroll down to our application, we can actually see the DNS name that would resolve the the web server that we'll connect to and make sure that the web service of the CAT web page is actually running. This would be the back end. We implemented a single instance of that application. However, we can scale that up, which we will do later. So at this point, we can see that my first app is working with the cats. As we refresh the screen, we should have a new image of a cat, which is pretty exciting. In console, we can see services. It does service discovery and can report any issues with services running in the Mantl environment. So we'll go into my first app, and we can see that we have passed our health checks for the services running for that container. Now we're going to go ahead and scale up. So from one instance, we're going to actually change it to 3 to make it a little bit more exciting in those regards. So from about, we were there with a confirmation. We'll go ahead, and now we can see that we have actually 3 containers. The VMs that they're running on are different. There's worker nodes that are VMs that the containers are deployed upon. We have 3, worker node 3, 2, and 5 with their individual ports that were assigned to each one of them. Again, they're fronted by a load balancer. Now what we're going to do is we're going to downscale back to a single instance, and as we go to our back end, we can see that we've reduced from 3 worker nodes to 1. We only have worker node 5 available. So the scale down did work, and now we were going to delete by sending an empty null into the marathon, and we can validate in Traefix that it no longer exists. We'll go into marathon and look for my first app, which does not exist anymore. So we have cleaned up our deployment of my first app, and that's all. So thank you for watching this demonstration of creating a container and an image in Docker, uploading it into Docker Hub, making it publicly available, grabbing that image from our Mantl solution, which is a tool set that focuses on container orchestration, and deploying those containers that were initially created on the laptop, and then being able to deploy them into a production environment using container orchestration. Thank you, and I look forward to you attending the next demonstration.